Okay, video here. Um, this is for AC circuit analysis, dealing with transfer functions. And the question is the transfer function is equal to s divided by s plus 1. Find the particular response when the current I is equal to e to the negative 4t cosine 3t plus 15 degrees in amps is applied to the circuit. So for this, what we need to remember is the formula S equals sigma plus J omega, where J here is the imaginary number, omega is the frequency, and sigma is going to be this exponential coefficient right here. So when we actually work this thing out, we get S is equal to negative 4 plus J3, which we see right here. Here's the 3t, that's your frequency. So now that we found S, we take this value, negative 4 plus J3, and put it back into our original equation here. So then our equation becomes negative 4 plus J3 divided by negative 4 plus J3 plus 1, again due to our original equation, which then turns into negative 4 plus J3 divided by negative 3 plus J3. So now we have one part of the equation. The other part, what it needs to be multiplied with, is we need the magnitude of the original current applied. So our magnitude is right here, 2. And then the phase angle is found right here, the 15 degrees. So 2 angle 15 degrees. So when we multiply this out, this all can go right into a calculator. On my TI Inspire, I put parentheses around the 2 angle 15, and I put parentheses around this negative 4 plus J3 over negative 3 plus J3. Your calculator may vary. So when you multiply this out, I've already done the work. It is approximately 2.36 angle 23.13. Your answer may slightly vary depending on how your calculator rounds. So now that we've come to this right here, we need to put that back into our original equation to get 2.36 e to the negative 4t cosine 3t, because our frequency doesn't change no matter what, unless it's combined with another frequency or whatnot. But our phase angle here plus does change. 23.13 degrees in a value of volts. So now part 2 of the question asks, it's the same transfer function, S divided by S plus 1, but the current applied is now 2e to the negative 4t amps. So we go back to our original S equals sigma plus j omega. Only in this instance, there is no sinusoidal function here. We have no cosine in this equation right here. It's just 2e to the negative 4t. That's just a dying exponential. So the only part that we have is this sigma part, which makes it easy here. So S is equal to negative 4. When we put that back into the original equation, well, I should say, so then we multiply, so we put it back into the original equation, negative 4 divided by negative 4 plus 1, we get negative 4 divided by negative 3, which is then multiplied by the magnitude. Magnitude right here is 2. And there is no phase angle, so we're going to have angle of 0 degrees, because again, there is no sinusoidal function here. It's just 2 angle 0. So this yields 8/3 e to the negative 4t. And I kind of skipped a step here, but you can see negative 4 divided by negative 3 times 2 angle 0 comes out to be 8/3, and then I just put it back to the original equation. So now we have 8 divided by 3 e to the negative 4t.